So now that you know a little bit about free body diagrams, we're going to do our introduction to statics, and I'm going to show you why we even care about free body diagrams. So statics are anything that's not moving, or it's moving in a uniform motion. Generally, we're just going to think about it as something not moving, but if it has a constant velocity and is not accelerating, it actually counts as a statics as well. So in general, it's something that's at rest or has uniform motion. So we need to talk about Newton's laws. There's 3 laws, and you need to write each one of these down. The first one is Newton's first law, and it says an object in a state of rest or uniform motion will continue to be so unless acted upon by a net force. For example, the book sitting on the table is not going to move unless someone comes by and moves it. If I have a hockey puck sliding across ice, unless something stops it or there is an amount of friction, it's going to keep sliding. Newton's second law is really just this formula at the bottom, force equals ma. And that's basically all this says up here in these words. So it says that the force is equal to the mass times the acceleration. A bigger mass means we get more force. A bigger acceleration means we get a bigger force. If you need to pause the video to take these notes down, you do need to have all these notes written down. And Newton's third law says for every action there is an equal and opposite reaction. For example, we saw that in our free body diagrams. If the book is sitting on the table and the book weighs 5 pounds, the table is pushing back on the book with 5 pounds. So static equilibrium. For a lot of what we're going to do in this, well, for everything we're going to do in this unit, we're going to have static equilibrium. The word equilibrium means when two things are equal. So this is where there's not some kind of there's not some unequaled force. Everything is rigid in our structure, and everything is staying at rest or just at a constant velocity. For our purposes, everything is really not moving, but it could be something at constant velocity. Okay, so translational equilibrium, translation, remember from geometry, that means back and forth, a translation, something sliding back and forth, is a state where there's no unbalanced forces. For example, in this bridge, there better not be any outside forces causing this to fall down, because that would be bad. Basically, we're saying here, this symbol means the sum. It means we're going to add up all the forces in the x direction being like this, and they're going to equal 0. Here we're saying we're going to sum, this is a capital sigma, we're going to add up all the forces in the y direction, up and down, and they're going to equal 0. For example, here, this is balanced forces. The bridge is sitting still. It's not moving. Here, where this bridge is collapsed, that's because there was too much weight on the bridge and it caused it to collapse. We have the same thing with moment that we looked at in the last one. Remember, mass equals distance times force. Here we're summing up all of the moments. For example, this moment going clockwise and the one going counterclockwise, and it adds up to 0. So what is a force? We've talked about it and seen it in our free body diagrams, but in general, what we're really talking about with a force, it's a vector quantity, like we said before, and it has magnitude and direction. In addition, we have to know where the point of application of the vector is. So what that means is, where is the vector starting? Here's our units for force. The British units that we use is pounds. And you also see lbf for pounds, meaning pounds force. There is also a pounds mass, which we don't use very often, but it's mass and not force. This is what you're usually going to see. And anytime it just says pounds, it usually means pounds force. The SI unit, the international unit, is newtons, and that's probably the one that you saw in physics. 1 pound is about 4.5 newtons, or 1 newton is 0.2 pounds. Be sure to write this down or notice where it is on your conversion page of your formula page. We just talked about the third law of Newton's third law says that they always act in opposite and equal reactions. So we're always going to have forces in pairs like this, vertical, horizontal, or moments. So one of the things we have to do with forces is break them down into their components. If I have a force going this direction, I can break it down into the part that's going vertical and the part going horizontal. Resultant force simply means what do I get when I add them up. Be sure to write this down what I'm saying because you're going to need this for the activities today. Resultant, that sounds like the result, and that's always when we add them up. For example, if I have something pushing on this box with 5 and I have someone else pulling on this box with 2, the resultant is that it's 7. That should make sense. 5 plus 2 is 7. Just as likely, if I have someone pushing this way with 5 and someone pushing that way with 2, the resultant is this person is really getting 3 pounds going that direction. And that's the end of our introduction to statics. Be sure you got all those notes. Rewind and pause if you need.